Good afternoon. In the hopefully following 15 minutes, I want to talk about the potential of interactive visualization techniques and user interface, user experience design for a better understanding of the stratigraphic record. I start with a short description of the problem I identified doing my work with excavation data. Thereafter, I'm going to propose some simple improvements for the user interface, user experience design of excavation databases, which I think could help to overcome these problems. For my PhD thesis, I'm working with data from 3 different excavations of the German Archaeological Institute, Taganrog, Selinuntim, and Los Castillejos de Alcorin. The aim of my research is to find a way, with the help of computational methods, to compare the data of those excavations and excavation data in general more efficiently in order to assist and augment the capacity of archaeological reasoning and interpretation. For this, it's not only important to understand the algorithms and their working, but also the data in detail in order to evaluate results of any algorithmic analysis. To get this overview and detailed information, I rely overall on the user interface of the database I'm working with. In this case, this is the data is recorded in IDA field version 1. I should mention a second version is in development at the moment. This is an excavation database of the German Archaeological Institute since 2009, and there are over 40-50 projects recorded in it at the moment. Also, the records are interconnected, as you can see, indicated by those lines. And you can jump from one record to the next. The interface mainly focuses on the view of one single record at the time, as you can see here in this data sheet of ceramics. And context is only presented as short textual information in a way that makes it very hard to get the big picture of the data you're working with. Tools like the Harris matrix, on the other hand, lack detailed information since most of the underlying data is not presented there. This is a problem of inadequate user interface design, at least in the context of the work I'm doing. In the following part of the presentation, I want to talk about some techniques to better combine the strength of archaeological sequence diagrams and database interfaces. One note: when we talk about those techniques, it's important to keep in mind that any proposed technique highly depends on not only the domain of interest, but also on the task at hand you want to solve. As seen here in this data visualization design model by Tamara Mansner. Therefore, my proposal may not be the best for every task you could imagine. The selection of interaction techniques I want to present here is best described by this mantra formulated by Schneiderman in 1996 in his paper The Eyes Have It. This is the original quote from the paper. He explains those techniques, and the first 5 of those techniques are of interest for us right now. Gain an overview of the entire collection, zoom in on the items of interest, filter out uninteresting items, select an item or group and get details when needed, and view relationships among those items. Besides this, we can use data visualization primitives to augment the experience, like marks for individual or aggregate data elements and channels for the data attributes. For example, mapping the unit type to a certain color, but also, for example, the results of data mining technologies to those channels. The first technique I want to show you is a well-known technique. It's a context-aware zoom functionality known by applications, for example, like Google Maps, where each zoom level offers you a different level of information. For example, in the first zoom level, you just get the number of the stratigraphical units and the type of the unit. Let's say if it's a pit or it's a wall or something like that, represented by the color. If you zoom in further, you get more information like the description, maybe a find distribution on the right-hand side, if you can see that, where the color encodes the type of the finds. This is mock data, so it's not real data, as you can see, so don't wonder. And for example, just as a proposal, if you have it, you could also map the volume of your stratigraphical unit to the length of this bar to get a quick overview. If you zoom in even further, you get more information. And what you absolutely cannot see right now is that this distribution changed, or this encoding changed from a distribution to little bars which encode every single record and record type, find type within the stratigraphical unit. And then again, if you zoom further, you may add some additional information like the photos of the units. Another well-known technique are tooltips, which give detail on demand via mouse, hover, and a click. The tooltips I'm proposing should be also context aware. That means you get different information depending on the zoom level you are and the part of the stratigraphical unit you are interested in. As you can see here, for example, if you go over the main body of this unit, you will get information regarding this unit. If you go over the distribution of finds, you will get a list of the finds with the counts associated with that unit. And then if you zoom in even further, you would get the individual finds within those units, or, for example, some more of the images connected to this data set. The next technique is one already known, for example, by the Harris matrix composer, a kind of grouping that gives you the structure and then detail on demand of the data you have. In the Harris matrix composer, as far as I know, it's only possible to combine one period and one phase. And if you're opening or closing those phases and periods, you have to recalculate the layout to get it right. It would be better, like in this case, that you get an arbitrary number of groupings, depending on your need, and also an arbitrary level of groupings. As you have seen with the units, you can encode additional information, like maybe the find distributions, aggregation of the find distribution of all included stratigraphical units, or, for example, with this bar, the number of stratigraphical units within this group. You can open and close these groupings, of course, and then you can use all the other techniques proposed, like zoom or tooltips or anything like that. I actually got a lot of inspiration from this paper, whose author I'm not going to pronunciate right now. And we don't have the time to discuss it in detail, but for those of you who are interested in this kind of visualization, it's certainly an interesting paper. They're trying to understand complex machine learning architecture with sometimes over 50,000 nodes. They got some interesting graph transformation and clustering techniques, edge bundling, and recursive calculation of the layout, so you don't have to recalculate the whole layout every time you open or close one of those groupings. Not everything of this would work for archaeological data, but certainly there are some really, really interesting ideas inside. The next technique I want to discuss would be a comparison technique. First, you can see, for example, the details, if you can see that, of one stratigraphical unit. If you click on it as a sidebar, where you can open or close those sections as you want and as you need. You can combine this with tooltips. In this way, you can compare, for example, two stratigraphical units, or if you want to see more than two stratigraphical units at a time, you can select even more, for example, 3, and you will get these detail cards of those 3 units, where you got the possibility to open and close the sections, and the sections would be linked to another and open and close together. You then can combine this again with a multiple view, where you, for example, can use a parallel coordinates diagram to see some of the attributes of the stratigraphical units you're interested in. Here we have got the find distribution, and then you could even provide some interaction if you want to. For example, I don't know, yeah, you can see it when you select this range of the specific find or attribute, which then corresponds or gives you the selection of the stratigraphical units. With 3 units, that's quite easy, but you have to imagine that you can visualize a lot more units with that technique. The last technique I would like to discuss is a search technique, an interactive search technique. Since this interface is connected to the database, you can enter a search term. You will get a proposition of possible matches alongside with the count of the corresponding stratigraphical units. When you select one of those matches, those stratigraphic units you're not interested in would zoom out or filter out. You could, of course, combine more than just one search term, and those units would gradually fade out even more. And as a possibility, you would have the option to look inside the single stratigraphical unit itself, go alongside the hierarchy and select one attribute, for example, a dating range. You would then select it and can even filter out more data. This, of course, works together with Zoom and tooltips and everything else I presented. A future idea or future step could be to use this kind of search as presented here in this paper by Pineta et al. For 2017, where you can visually search the stratigraphical units like seen before. This would then get translated to a database query, in this case a cipher query for the Neo4j database, and then you got some kind of pattern or subgraph matching or fuzzy matching, however you want. So you will get back the subgraph that corresponded with it. Of course, that makes only sense if you are working with more than one database and have a lot of stratigraphical data in your database. Lastly, I should mention that this has been more or less a design model I've presented here. I'm actually implementing these things. These are the techniques I'm using for those who are interested. And last words, yeah, I think often when it comes to development of archaeological applications, user interface design gets not the attention which it should get in order to really work efficiently with the data at hand regarding the task you want to solve. Thank you.